Hello friends, welcome to classs12.com. Now in this video we will learn about the esterification reaction. What is an esterification reaction? This is the synthesis of an ester from the reaction of alcohols and carboxylic acids. So that means when we react the alcohol with carboxylic acids or COH, the reaction is reversible, and in an acidic medium, what you get? You get the esters here, right? The hydrogen here from alcohol reacts with the hydroxide and you get the water there, right? And then you get an ester also, or C double bond O OR. Okay, let me mark this one. So that means you get an ester here, right? This is an ester, and the formation of the ester can be identified with the fruity smell, right? Okay, so when you carry out this reaction in a beaker, in a vessel, what do you find? If you find some fruity smell there, right, after some time, it means that ester formation has started. Okay, so basically this is a reversible reaction. That's why there's an equilibrium, and you can shift this equilibrium toward the product side, toward the esterification, towards the esters, by draining out this water continuously from the reaction mixture, so that the equilibrium will shift in the right direction in the product side. Okay, so let's take here an example. If you take here the CH3 CH2 OH ethanol with acetic acid, right? CH3COH here, right? So in the acidic medium, when you add some sulfuric acid, so what will happen here? The hydrogen from this one reacts with the OH and you get the water. Okay, plus what else you get? This group CH3 C double bond O now will be under the attack of this oxygen. The oxygen here will form a bond with this particular carbon, and so it will be the oxygen there, and then you get the CH2 CH3 here, right? Now this is an ester, RCOR. This is an ester here. So this is an esterification reaction. Okay, esterification reaction. This is called as an esterification reaction. Okay, in which ester is formed. Now, looking at this, esterification reaction, the reactivity of the different alcohols and the carboxylic acids is different, right? Suppose if you have a formic acid, right? Formic acid is HCOH. This is the most reactive, carboxylic acid, right? Among all the carboxylic acids towards the alcohol, right, in the synthesis of an ester. So this is the most reactive, carboxylic acid. And then if you actually increase the size of this alkyl group here, the reactivity of the carboxylic acid will decrease in the esterification reaction. Okay, so the order of reactivity of the different carboxylic acids can be written as formic acid. Since it is hydrogen there, it will be the most one, right? Maximum one. Then you can say it is the CH3COH here. Okay, and then you can say CH3 CH2 CH2 here, COH. As the alkyl, the size of this alkyl group increases, the reactivity will decrease. Correct? This is the order of reactivity. Order of reactivity of the different carboxylic acids. And similarly, the reactivity of the different alcohols, right? What will be the order of the reactivity for the alcohols? Okay, again the pattern is same, right? If the size of this alkyl group increases, right, size increases there, here in alcohols, when with the size, with the increase in the size, the order of reactivity decreases, right? Reactivity of the alcohol decreases there. Okay, so that means methanol will be the most reactive one because it has got only one carbon atom, and then it will be the ethanol, CH3 CH2OH, and then you can say propanol, CH3 CH2 CH2OH, right? This is the order of reactivity of the different alcohols. Now what about acetylation, or you can say acylation? Acylation is a general term, right? Acyl group is actually RC double bond O. This is called as an acyl, right? This is an acyl group here, and we can attach the acyl group here, right? We can add an acyl to the alcohol. That's what we call acylation, right? So what you get then? You get again the ester. And how we do it, how the acylation is done. Acylation can be done when you react the acid chlorides. Acid chloride is RCOCl. Acid chlorides, when treated with the alcohols, so hydrogen here reacts with the chlorine, okay, and you get the HCl. What else you get? Now you got an acyl here, or CO. Here this RO bond, RO group, it will attach to the acyl group and you get an ester. So ester can also be prepared by treating alcohols with the acid chlorides, okay, and the process is called acylation because we are attaching an acyl group to the alcohol, right? We are replacing the hydrogen here by the acyl group, okay, and this acyl group you can also get it from anhydrides, right? Not only from the acid chlorides, right? This is an acid chloride. From acid chloride you can get an acyl group that can replace the hydrogen from the alcohol. Even you can carry out the same reaction with the anhydrides also. Anhydride is like this, RCO, O, carbon, oxygen, and this is an anhydride, right? So with the anhydride also, when you react to the alcohols, so here the bond breaking takes place here, okay, so acyl group now from the anhydride replaces the hydrogen, and what you get? You get RCOOR, which is an ester, plus you get a carboxylic acid here, right, or COOH, because this particular hydrogen will now react with the oxygen here, okay. The bond breaking takes place here, acyl group now attaches on the oxygen, right? You get an ester here first, and the particular this hydrogen which is replaced there reacts with the RCO group and you get the carboxylic acid, right? This is called acylation. And if you have an acetyl group, acetyl means like this, suppose you got the CH3 C double bond over Cl, right? This group is called an acetyl, right? When it is CH3CO, this is an acetyl group, okay. So if you react the this molecule with the alcohol, you get an ester, right? So the formula will be the CH3 C double bond O and OR here. In this case, this process is an acylation in general, and acylation is a general term, but we can call this reaction here as an acetylation, right? Because we are attaching an acetyl group, so this is an acetylation. Plus what you get here? You get HCl. Hope you got the concept. Thanks for watching the video. Bye for now.